For number 1, we're trying to find a conditional probability, the probability of F given that E has occurred. And from the formula, we know we would solve that by putting the probability that E has occurred on bottom and the probability that E and F occur at the same time on top. And so from the problem we have, that's 0.1 over 0.2, which is 0.5 or 50% of the time. And to help visualize that, we're trying to find the probability that F is going to happen if we know that E happens. So we know that we land somewhere in the E circle. What's the chances that we're in the F circle as well? So what's the chances we're here in the overlap? Well, the whole E circle happens 20% of the time, and half of that, 50% of that, is in the overlap, 0.1 of the entire 0.20. So 0.1 out of the entire 0.2 is 50%. And for number 2, we're trying to find a conditional probability. What's the probability that event F will occur if we're given that E has occurred? And from the formula, the number in E and F goes on top, the number in E goes on bottom. We get 280 over 560, which reduces to 0.5. And to help visualize, we're trying to find the probability of being in the F circle if we know for sure that we're in the E circle. So if we're in the E circle for sure, there's 560 total possibilities. 280 of them are also in the F circle. So 280 out of 560 is 0.5. For number 3, we first want to know what's the probability that a card drawn from a standard 52 card deck is a spade. And that's going to be 1/4 because there are 13 total spades in the deck. There are 52 total cards. So 13 out of 52 is 1/4 or 0.25. And the second part was, what's the probability that the card drawn from the deck is a spade if we know that the card we drew is black. So now we're trying to find the chances we get a spade if we know it's black. If we're given that it's black, there's 13 spades still, but we're given that it's only one of the 26 black cards. So now we have a 13 out of 26 chance, or 1/2, 0.5. For number 4, we're given some statistics about high school dropouts that are between 16 and 17, and also the percentage of high school dropouts that are between 16 and 17, and in addition, they are also white. To find the probability that we randomly select a dropout and that they're white, given that we know they're between 16 and 17, we'd set it up like this. The probability that the person is white if we know they're between 16 and 17-year-old dropout. So set that up like any conditional probability. The chance you put the probability that they fit both these conditions on top, they're white and between 16 and 17-year-old dropout. And then the probability of the conditional part that you're given goes on bottom. And so you get your numbers from the problem, and it comes out to 0.6512. And again, to visualize it, if we're given that we're selecting someone who's a 16 and 17-year-old dropout, there's a total of 8.6% in this entire circle. What's the probability that that person is also going to be white? Well, 5.6 out of that total 8.6 is also in the white circle. So 5.6 out of 8.6, 0.6512. For number 5, we're given a table here that's broken down by gender and also age group. And you can open that in StatCrunch or copy it to Excel, but you want to somehow put it in a table and then keep track of the totals for each column and row. So add up the total number of men there are, the total number of females, and also for each age group, the total people under 16, the total between 16 and 20, etc. And then all your totals this way should add to the same number as your total of male and females add to. And then use those totals to answer the questions. The probability that a randomly selected driver fatality who was female was 21 to 34 years old. So we're only looking at the females, and we want to know what the chances between 21 and 34 years old. So the probability, there are 4,461 females who are 21 to 34, and there's a total of 16,270 females. So that's your probability for A. For B, the probability a randomly selected driver fatality who was 21 to 34 was female. So what's the probability that we get a female if we're given that if we know they're between 21 and 34? So we're looking at the people between 21 and 34. What's the chances they're female? Well, there's 4, 4, 6, 1 that fit that. And out of the people 21 to 34, 4, 4, 6, 1 divided by the total of people who are 21 to 34. And then round that, you get 0.231. And part C, is a victim of a fatal accident aged 21 to 34 more likely to be male or female? Well, they got to be one or the other. If this is their chances of being female, they're going to have a much larger chance of being male. You can just do 1 minus 0.231, the complement rule. This would be the probability that they're male, 0.769. So they're more likely to be male. That's over 50%. You can also use the table. And so between 21 and 34, there's 14,849 males, and the total is 19,310. And so you get the same probability when you round of them being male.